Hello and welcome. I'm Bill Wake. We're working on a basic interpreter written in Swift, and we've done a lot of the work around expressions, and we did the for loops, and we did GOSUB. Now we're getting into things that aren't in the original basic, and the first one of those we want to focus on is multiple statements per line. Actually, we've done a little bit of function stuff, but multiple statements per line. So there's kind of two versions of this. There's one is that if statements, instead of just being if condition, then line number and being an implicit go-to, you can also say if condition, then statement. So the statement might be print x. So if c equals 1, then print x, and it will do that if c equals 1. All right. The second version of multiple statements on a line is that you can separate statements by colons and put them on a single line. So x equals 1, y equals 2, print x. You don't need separate lines for that. All right. Now, there's a challenge here. The first challenge is this is ambiguous. So I've got x equals 1. If c equals 2, then y equals 3. If d equals 4, then print d and print x. And so the question is, does print x always get run? Are these sort of like four independent boxes? I mean, I could definitely see splitting our lines on colons and saying, okay, each box is its own thing. First box, x equals 1, done. If c equals 2, then y equals 3. Well, c doesn't equal 2, don't do that. Next box, if d equals 4, print d. No, don't do that. Okay, print x. So does print x always run or not? Okay. Another interpretation would be, okay, the x equals 1, we do that, but then we're going to do the rest of it is one if statement. Okay. And if condition c equals 2, then we're going to do the statements that correspond. So then y equals 3, if d equals 4, print d and print x. In this case, we're saying that the print x attaches to the first if statement. So it always runs if c equals 2. Okay. And the third interpretation, and maybe there's more, is each if statement sort of nests. And so if c equals 2, then y equals 3. Yes, we'll do that. Then we'll do if d equals 4, print d and print x. So if I think of it as kind of precedence, I'm sort of saying the colon has lower, let's see, that it has higher precedence than the if statement, but lower than most of the other statements in effect. Okay. Or I might think of it as right associative. You know, I want d equals 4 and then grab as much statement as you can. Now in Pascal and C, if statements have this thing where you can have an ambiguity about an else clause. So if you have if this, then, if that, then, and then you say else, does the else attach to the inner one or the outer one? And it's basically the same ambiguity we're looking at. And the answer is that most languages say, well, attach it to the innermost, okay? Or they have, end if or some braces or something to tell you where it goes. But, if there's that ambiguity, then they tend to resolve it that way. And it's a trick in the grammar, in effect, or a quirk in the grammar maybe. But, if it's all independent things and they don't matter, then you don't have to worry about it so much. But if some things have precedence, then you do have to worry. And so the question is, which interpretation is right? So they can't all be right, because in the first one we always print x, in the second one we only print x if c equals 2, in the third one we only print x if c equals 2 and d equals 4. Okay. Well, the answer we're going to use is the first two are not the interpretations we want. We're going to kind of like that dangling else issue. We're going to take the nearest innermost statements and attach those to that if statement. So if d equals 4, then print d and print x. Okay. Now, I don't know, implementation wise, could you get by with the first version? You might be able to. But I'd like to make our tree reflect the semantics we really want. So rather than having a tree that is very flat, and we sort of know that, oh, if this one happens, then break out of the tree or whatever, I want to be more explicit, and that structure on the bottom is going to, the if statement is going to have multiple statements in it. And and they're gonna, that's gonna be that last half there. I think that'll be better from the interpreter side, and it'll be better when we get to the compiler side. Excuse me. All right. Well, if I call it challenge 1, that probably means there's a challenge 2, right? The second one, it's not such a big deal, but it is. There's sort of a pseudo else. So the old basics don't have else clauses, but you can kind of simulate it here. We got if x equals y then 50. That's the original if then go to kind of thing, and in this case, if it's true, then it goes to 50. If it's false, it goes ahead to the next statement and prints m. Okay, so it's kind of like an else clause. But then you have the contrast, the one on the bottom. If x equals y, then z equals 2 and print m. That happens only if x equals y. So it's a little, it's not ambiguous, but you have to be a little bit watchful because you can end up with some situations with else's and some with not, but you never have the word else to help you. All right, and I don't know if you're surprised, but there's a third challenge. All right, I've mentioned this one in previous episodes, I think. So if we have for I equals 1 to 20, colon print I, colon next I, well, normally our next statement jumps back to the line after the for statement. If this was line 25 was print I, we'd jump to 25. But now we don't have a line number to jump to. We can't jump back to 20 or we'd start the loop over. So we've got to worry about locations that are inside lines. Unfortunately, I guess, really. Although maybe it doesn't matter. I mean, most languages, right? You have sequences of statements, and you can jump back to them if you need to with ifs and whiles. All right, and the same thing happens with GOSUB. So x equals 1 GOSUB 3000. We jump down to 3000. When we return, we want to come back and print y. We don't want to go to line 31 or 35 or whatever's next. Okay, so that's definitely a challenge, an implementation challenge. So I think we'll focus on the if statement first, then we'll get the statement structure together, and then we'll address for and GOSUB because they are not going to tolerate line number based jumps. All right. Okay, so multiple statements on one line, and really let's start with this one. If relation expression, then statement. I guess. All right, and we'll go down to our grammar, which is a little sloppy these days. Okay, line number statement. If expression, then integer. Well, we can also have statement. If expression, then I guess I should have been quoting that too. Then statement. Okay. And yeah, we'll have to address that I guess the inner statement won't hurt so much. All right, but it's a little different. Up till now, our statements have not been recursive, and now we're adding that statements can contain statements. All right, and that's actually kind of it's a bit of a deal in the language terms, that we're allowing this full nesting. We had it in expressions because expressions can all, addition is expression plus expression kind of thing at some level. All right, so we want if expression then statement. Notice we got the same leading part. We could break it out into statement goes to if expression and then choose between these two, and that's how we'll implement it. It's I forget what you call this, left something, but you can pull out prefixes that are common and then just go on the difference, so you don't have that kind of look ahead you might need in this case. We don't need to look ahead really. Excuse me. We had a bunch of storm and tornado warnings last night, starting at 11:30 p.m. until about almost 2 a.m. I think I'm a little rough from that. Alrighty. Well, we already have if, expression, then, and we already have statement. So in that sense, we probably don't need any Lexing stuff added. We're probably getting close to the end of the Lexing changes. I guess we don't have colons yet, so we'll need that eventually. All right, but the parser, let's find our if statement. Dim for next. Okay. Still kind of. Gosh, I really am feeling like an expression parser might be a good thing. Let's pause and extract that first. I don't know. I'm feeling these large files. Let's extract an expression parser. Okay, so the goal of this thing is provide this method. That's kind of the top of it. Okay, and power down to factor. Parenthesized, numeric factor, variable. Predefined function call. All this stuff is expressions. Ugh. It's really quite a pile of stuff. Okay, down to there. Let's copy that. All right, now we must have forgotten some stuff. Okay. Cannot find token. Oh, that's going to be a challenge. Token. Because today, parser knows token. Well, that's probably the reason we haven't done this before. This is going to be messy. So do I need to reference parser token everywhere? Okay, so maybe this lexer.next. Maybe we should be sharing the lexer. The problem, well, lexer of input. Yeah. Okay. Let's belay that. Okay, so I'll make a new version of that. Can we move token to the lexer itself? Then share the lexer between parser and a new class expression parser. Okay, we'll try that. Okay, so back that out. All right, and yeah, let's make a little header here. All right, if relation expressions. Well, let's jump in and do that one. pulled the expression tests out. Interesting. Okay. Parser tests. So let's find our if statement. If it's line number. Okay. Okay, so what do we expect? Well, it's going to be, let's rename this to if go to. And this, I think we'll keep the old if name. Excuse me. It's number 1. And I'm going to assume a list of statements, even though we don't really quite support it yet. Print number 42. Okay. Statement has no member if. I think if we add this, we'll get there. We'll need an expression and array of statement. Okay, and for now there'll only be one, but we will get there. Okay. Expression has no member. Oh, print is prints a array of things, I think, yeah. Oh, right after this one. And this statement we expect to fail should get an error message about something. Oops. All right, we got an exception, an error message, missing target of then, because we didn't have a number. Okay, and that's good enough to get us going. All right, so the if statement, assign, define, go sub, go to, if then. All right, we get require missing then. All right, here, if it's an integer, then we're going to do this and return an if go to. If it's not an integer, now instead of parse error, we're going to look for a statement. Okay, and so let's see. So I guess we just need to catch it. Let statement equal try statement. Okay. And let's see this. So you can see the grammar change. It's not that much of a change. So you can see that it was probably relatively cheap for them to try and do that from this perspective anyway. Now we're going to have a conflict in our error messages in some of our tests, at least one. Yeah. Okay. We got unknown statement. Okay. Instead of missing target of then. And I think that's really accurate in the sense that you are looking for something there. I don't know. You could probably get a more specific message, but eventually we'll have a little arrow pointing right after the then going unknown statement. Okay, I think that'll be close enough. Okay, so let's check everything again. All right. So we added parsers support for if followed by statement. All right, and then our interpreter. Well, let's see what if then does. Yeah, that's pretty simple. Okay. Let's make a test. Okay, so if one, then print 25. My optimistic self will fix the indentation, knowing it will break the next time I reformat. Okay. We'll get an NYI. can't happen. Okay. And our interpreter. Well, we'll make a do if. Okay. Case with the if. Okay. We get a line, an expression. And statements. All right. So we certainly evaluate our condition. And then if the condition is not 0, meaning true, then we're going to evaluate our statement. And for now, well, let's see. Is that I guess that's step. Oh, I'm really... This output thing is not good. Okay. What I really do want people to just append to it when they need to. Okay, so I guess we'll have to call statement on each statement, which is also a parse, no problem there. The output, I think our darned if is going to have to do it. Let's find print. Yeah, it's going to be similar to that. Ugh. Okay. that if that thing's going. Okay. Output a string. How do we do our print? Oh, we passed it first. Okay, we'll do that here too. All right, we've got the statements. For each statement, what do we want to do? Well, I guess we want to get, oh, we're going to have to capture it. Okay, so we're going to have to do let, oh no, what is it? This whole output thing is driving me crazy. Okay, what does step do? It takes an output string. It may append to it. Okay. Throws and returns a string. Okay. Equal step well, step takes the parse $0 and it takes an output. Which is kind of like the whole output. Okay, if we don't do the condition, well, we'll just take the output we had. That much I know. All right, so we're going to compute the output based on that. Cannot convert statement to parse. Oh. Parse is line number and the statement itself. Okay. Because we're still in the same line number. Calc and throw, yes. I don't know if I need them both. Okay, so output 1 is the resulting output from this thing. Let's try this. Result, let result, var result equals output. Okay, too big a step, I think. And then at the end, we want to return result. That much I know. And then I think if we do it like this, let's just capture the output from each one. Like that. Okay, so we will take a step, start with an empty output, so gather the output from the one step, accumulate that on top of result, and keep doing that for each statement. And at the end, we'll return it. So this is if condition is true. Okay. Let's run our test. Okay. We've done a FOR here. Right now we don't have enough to prove that that's possible because we don't support that colon extra multiple statements yet. I think we may have done enough to go there. Let's make sure we let's add something here. It's like we want to do test if with multiple colon separated statements. Okay, but I think we've done the basics of this. I mean, it wasn't too bad. The topic is multi-line, multiple statements per line. And we did if relation then expressions. Okay. Well, yeah, that wasn't so bad. I'll move this down. Okay. So let's take an easy case first. Something like, I guess I can write a test, right? Maybe right here. Okay, so test multiple statements on one line. What do we expect? Well, we're going to have to invent something for it, I think. So if we do 10, print 10, print 20. Okay. What are we expecting? Well, we're after the parse structure. So I'm going to say sequence. Is that a good way to do it? I think it might be. Okay, so a sequence, and that takes a list, and it's going to have a print with dot number 10, and then a second print number 20. Okay. Oh, I don't have that here. Okay. Sequence print number 10, print number 20. Okay, sequence doesn't exist in our parse. And it's a statement type. Okay, so let's see if I can add it to the interpreter this time without forgetting. All right, sequence takes a list of statements. All right, and interpreter needs a case for sequence. I think I can do it like this. Throw interpreter error dot error. Can't happen. Okay. I guess only the test there. Okay. Multiple statements on line. Good. We expect it to fail because nobody knows about sequence yet except the parse. Okay. NYI. Extra characters to end a line. Okay, I can accept that. Yeah, because we don't have a colon yet. I forgot about him. All right. Let's go to Lexer. And we'll need token. All right. I don't mind. I mean, we use this approach of lists of stuff, and I don't think we don't test every single thing off this list. So I'm going to be all right. Add that in. And we do have a failing test that will kind of cover it. We may get a different message now instead of extra characters to end. Oh, I guess we'll probably still we'll get a complaint, expected EOL or something like that, I think. Extra characters end a line. Okay, so it sort of shifted from an unknown character or an unknown token to a known token, but not expected there. Okay. All right. The thing is, if we have the colon, we want to see a sequence. If we don't have the colon, I don't really need a sequence. Okay. So let's go into the parser. And this is really high up. Okay, here's our statement. Try statement. So up here, a line, we say a line starts with a number, then it has a statement. And then well, we want to add support for a colon here. Although maybe we need another level in here. Okay, so let's try statements, and let's just stick a new level of colon here. So function statements throws returns a statement, and all it does is return try statement. Okay, is that gonna work? I guess every test but one should pass, right? Okay, that one test failed still. Good. Parser. All right, so now this thing doesn't care. The line just assumes it'll come up with something. Okay. If all right, so let's let statement equal try statement. Okay. I guess if token is not a colon, then we're just going to return statement. And I'll return statement here just to prove that we're not off track yet. Okay, one failure, the one we expect. Okay. If it is a colon, well, while it's a colon, we're gonna get more statements. Well, let's see. Let's figure out a list to hold our statements. Actually, we can put statement in there to start with. We got the first one. We're going to skip the token, and we're going to let statement equal try statement. and result.append statement. And then at the end, we want to return a sequence. Well, let's call this statements. Okay, fine. Let's, oh, can I call value of non-function statement remove? That doesn't seem right. Maybe I can't reuse that name. Yeah, thought it was the same. Ugh, okay. Let's inline this. Okay, so we try statement. If we don't have a colon, then we just return the statement we found. Otherwise, we start a list of statements with that first one, find colon followed by statements, and append them in, and then return the sequence at the end. And I believe this should work. We haven't addressed if yet. Yeah. Okay. So we support, let's see, support parsing of colon separated statements at top level. Okay. And then let's interpret them. Okay, so right now we just do this. Okay. That output thing is going to get fixed. Oh, I don't know. Do I fight through this? Okay. Let's go back to early statements. Print. Okay, simple print. Yeah, that's more like it. Okay. Let's test multiple print on one line. And we'll print 35, print 36. Maybe I'll just use different numbers just to kind of make sure everybody's honest. Now we expect our NYI. Okay. And sequence. Okay, so, well, let's see. Unfortunately, we're going to have to do the same thing. So return try do sequence. And this has statements, output, and statements. Okay. So to handle a sequence of statements, do sequence and deal with the output and return that in place there. And I don't know, that's almost more fundamental than expressions, I think. Let's do it here. Okay, so if we just return output for now, this is throws, returns a string. All right, this is going to look a lot like that if. And I don't know when we want to fight that one off, but I'm looking for my do sequence. Okay. Result equals output. For each statement, add in a step and return result. Okay. And let's run that. Okay, and since this we just copied, well, let's check it in. Okay, since do if wants to do the same thing, let's go back where we stole this code. Do if, okay. Well, this code is do sequence of output and statements. Okay, so that should be the same. Okay, let's see. So where are we? Multiple statements on one line. At top level. Then we got to deal with if, let's see, so if with multiple statements, and then we have to deal with a for statement returning to middle of line, GOSUB returning to middle of line. This one I believe we've done. Single statement only for now. All right. And if with multiple separated, okay, I guess I should spell that out. All right, that's a good place. I'm happy with where we are. The if, I don't think, yeah, I think we can make that go. There's something funny in parse though. This, I think we can make this go back to just being a single statement because sequence covers this case. So I think we'll do that. We'll see how it goes, but I think we'll want to do that. But otherwise, I think we're set that the next thing we want to do is the if statement, if with statement, I think we want to do an if with multiple statements. Print 43. This should come back with another print. Okay, if with multiple statements. Believe that will fail. Well, not for that quite reason. If number 1 print number 42 parend print number 43, close that, close that, close that. That's an extra. Okay, that should fail. All right, and the error was sequence. Yeah, so we got a sequence with an if statement and a print. So the print was attached to the if statement, but we have a top level print. Okay, so it was. This is kind of that ambiguity. So we interpreted it as 2 statements at the top level, but that's not what we want to do. So we got to make some changes to support that. So we're due for a break. So let's take a 3-minute break or so, and we'll come back and get the multiple statements working in the if there. Hey, welcome back. Alrighty, so yeah, basically the problem is our parser here just looks for one statement. We want it to be greedy and grab these 2 and say, oh, I've got a sequence of statements. And then the top level parser will never get a chance to try and grab the print 43 because it's already been consumed by the print, by the if statement. Okay, so we go down to try to if parser. Yeah, if then. Okay, so statement equals try statement. Well, now what we're saying is it should try statements. Okay, so let's go back up here. Remember, we just put this method in that handles the colon and returns a sequence. Okay, so we should return that. We should get one of those too. Okay, so this change here, and then yeah, okay. I think that we'll see that it returned 1 level deeper than we need. Let's run. Okay, so what's returned? All right, so we were expecting an array of 2 statements. Okay. Here we're expecting the array of these 2 print statements. What we got was a sequence with an array of 2 print statements. So in there, okay. So the reality is well, how can I make this right quickest? I guess we will fix our expectation first. So this expects sequence, and Where's the bracket for that? That, and then the sequence holds an array as well. Everything gets so nested. Is it there, I think? Yeah. All right, I think that's going to do it. My formatting's a little off, but okay. Yeah, so, well, let's, so parser supports greedy parsing to get multiple statements. So this is, yeah, what's going on is we've got an array of statements, but the way our statements parser works is it always just returns a sequence. So there's not really a point to having this array here. So let's take this out. All right, let's just return a statement. Okay, no brackets there. Okay, this will break people. Okay, if then is just going to return the statement. Okay, and then interpreter, it's got statements, but doIf is currently expecting an array. Okay. Now, statements do sequence. I don't think we want to do a sequence. I think we just want to do a step. Okay, because step is the thing that handles multiple, it handles the specific statements type, and we could just have one single statement, or we could have a sequence down here. And we just want to handle it. So let's go down to doIf again. Okay, so let's do a step. And let's just say statement. And I think does step put output first? No, it's backwards. That's weird. Okay. So we are saying if an if statement only has a statement as its right-hand side, then we will execute the statement and, well, we'll evaluate the condition. If it's true, we will execute the statement that we were given. Oh, and is it a parse issue? Yeah. Okay. So we'll wrap it in a parse. Maybe that's not what we need, but that's what we'll do. Okay, we'll wrap it in a parse and just execute it with the output. Yeah, accumulating the output. Okay, let's make sure if this works. No. Okay, tests that expect multiple things. Okay, this one does not need the array. Okay. To close print, close if. cannot convert any to expected type statement. I feel like that's not quite right. This bracket goes away. Any to expected type statement. I don't know what this complaint is. Let's make sure parse takes a statement. Okay, if, number one, if takes two things, this and a print 42 parend are these all the same complaint? Okay. Xcode. All right, so we've made .if take a single statement, which can be a sequence rather than a list of statements. All right, so now let's test nested ifs. Nested ifs with multiple statements. Okay, if 1 print 42, if 0 print, then print 43, and print 44. Okay, so it's an if number then sequence. The if has two things, a print 42 and another if which has a number 0 and a sequence which, whoops, don't do that. Okay. Which has a print 43. All right, let's get that much. And a print 44. Okay, we close. Oops, we didn't close the right sequence. This sequence needs to close. Close that, close that, close that. Close this sequence, close the parend. Close the if. Close the sequence, parend. close the if and the statement. Okay. Now, let's make sure if number one, then a sequence, which is two things, a print and an if. The inner if has number 0 and a sequence of print 43, 44. Okay. This should pass. Yay. Okay. That's, yeah. So if, let's go back to our opening stuff. Okay. So here, that kind of corresponds to this case. We didn't do that part, but we made sure that the last if statement has all the trailing statements, and those are the inner piece, and this is a pair of pieces next, based on the outer if, and we've resolved it the way we wanted to. If we hadn't, it would look like a sequence of X, if, print. Okay, like this first line. Yeah, that's good. And that was nice. The fact that it worked like that just means like everything was already in place. That we did everything right, and so they all fall in. That recursion of statements looking for statements, we're doing okay. If with multiple colon separated statements. All right. Okay. That's good. All right. Now the tricky one. I don't have a good answer here. I have an idea. All right, but let's write an interpreter test. Okay, find our for statements down towards the bottom, I think. Test for with negative. Okay, so if we wrote 10 for I equals 1 to 2, print I, next I. In principle, we should get this. Okay, each I printing itself. What's gonna happen, I don't even know. Well, let's make a multi-line program out of this. That'll be better. Okay. If we had this, I would expect 1, 2, and then 20. What I think will happen is, I think this will say, set up my following line as line 20, and next I should go to my following line. I think it'll do a print. I think it'll just print 20. And maybe complain that nexts weren't exited. Oh, yeah. Okay, so the problem is when it's in line 10, it says, okay, let's find the next statement. It starts scanning at line 20 because that's the following statement. Well, the solution or the intuition I have is that what I should do is make my locations be more complicated. So they can't just be line numbers. They've got to be a line number and a sequence number. Okay. And so the for statement is really line 10, sequence 0. And the next statement following it should be line 10, sequence 1. And it should fall through those. Yeah, because I mean, what if I had split it here? Ignore the colon, but um, I would still need to look for that next I at the end of the line. Okay, so let's work on making that more possible. Okay. So I'm going to add this for later. We're going to need to make current line more sophisticated. Come on, give me a little help there. Okay. And to some extent, well, I want to say it's refactoring, and it kind of is. All right, so way back when, well, we have this type line number. Okay, and next line number. I think I want to make a location. So let's make a struct location, and it's got a line number. Let's see. Look at token. Do we need the column number? I don't think we do. Okay, so let's just get the line number of type line number, and then I want to say like sequence point, subline number. Like that. And then I think I want to use location instead of line number. Let's put them in parallel. Okay. And let's try and get them consistent throughout. So whenever I change line number, I need to change location. All right, so let's find references to line number. Return stack. Well, I'm pretty sure that should be location. Okay, and let's see who complains. Build-wise. Append program.line after line number. Line after line number returns a line. Maybe I don't want to start there. That would be a good one to fix, though, because that would deal with the GOSUB. But let's put it back. Let's go see our FOR info. Okay, well, let's make location equals location of line number column 0. This bit is definitely going to be more complicated. Maybe this sequence thing is not the best way to do it. I don't know. Let's see. Let's just add a constructor. Yeah, it's really every assignment to line number. All right, if we change line number, we got to change location. And we're always 0 so far, so that's okay. Let's find that. Line number equals. Okay. So I think what we've done, we've put in this parallel structure. Whenever you assign line number, you always assign this structure. Okay, so let's run tests. Don't need to blow up. So add location maintained in parallel with line number. Okay. So now the insight I want to have, or the thing I want to take advantage of, is any reference to line number now is the same as location.line number. Okay, so here we could say location.line number because we've already stored the location is the same. So any reference to line number, bare reference to line number, can be changed to location.line number. Okay, and I think we should be able to do them one at a time. It's not going to hurt anything because every write takes care of it. Okay, so now if we find references to this symbol, there are a bunch. Okay, that's a set. We took care of that. Okay, location.line number. Here, this one. Let's flip that too. So let's say I'll just say temp, good old temp, equal that. This equals temp, and then let's set line number equal location.line number. Okay, is that gonna work? It should. Good. Okay, so now the setter, let's flip the order. Let's put this as primary. Line number was 0. Okay. I don't know if I can make this reference in the initializer. Okay. Okay, so make location the primary place to find the line number. Okay, so I've sort of changed the status. So instead of location being the shadow field shadowing line number, I've made it the other way around. So any assignment to line number is now coming from location. Now I want to make sure any reference to line number is coming from location instead. Okay, so again, I'll look for the symbol. I don't think it's quite as semantic as I wanted, but okay. Location.line number. Okay. Program subline number, it should be able to say location.line number. And we tried to pull out a function to do this throw for us, and we found out we just can't. Maybe we can try again with this in place. But notice that almost all of the references to line number or the error messages once in a while, there's one that isn't. Okay. For go to, go sub, those kind of things. And again, I should be able to stop in the middle, run tests. Okay. Go back to find. Is this the for loop? Yeah. Right, that should cover all of them, and they should pass. All right, so all former references to line number now refer to location.line number. Okay, and this approach of doing things in parallel lets us keep both ways running at the same time until we're good and ready to switch over. If I'd switched over first, I'd have all of these places that were saying like you have to get the right line number, and that would be hard. But now this, I don't think anybody needs this variable anymore. Okay, there'll be a couple complaints syntax wise. Yeah, we assign it, but nobody's looking at it, so there's no point to it. Okay, eliminate line number. Okay, now I wish things were going to be easier, but I think it's going to be painful. All right. The problem I see, this is where we're going to pay the price for this sequence object. Well, let's put it like this. I think I would like to say print D is some sort of sequence 0 and print X is sequence 1, but it's really like a sub, a sub, kind of a within thing. In this one, this is 0 and 1, and this is 0 and this is 1 within that. So it's like slot 1, slot 1, slot 0, slot 1. It's got to be recursive. That's the way I'm seeing it here. That's That's hard. It's really tricky, isn't it? Okay, so I guess when you're stuck, right, you got to generate ideas. All right. One is I could have some sort of hierarchical specification of the location. So print D is 0 dot, or it's 1.1.0. Maybe I'll write these down. Hierarchical numbering. Another option somehow it seems because you're always, I don't know, like you're always getting this stuff at the end. It somehow seems we don't need a full hierarchy, right? Because once you get the only way you can go down is in an if. Only ifs take you deeper in the hierarchy. Although this does make me wonder if sometimes you have restrictions like you can only have 10 of these within those. So if you can only have 10 statements in a line, okay, well, yeah, I mean, I could imagine level 1 gets the zeros, level 2 gets the tens, level 3 gets the hundreds or something like that, you know. Well, I guess I should record that. Another one would be hierarchical numbering 231, limit to 10 statements per level. Another option. See, I wonder if I could index them. If I split out the nesting from the, what am I trying to say? Well, basically, I want to index them as if they were done this way. So this is 0, this is 1, this is 2, this is 3. And then how do I map that forward? I guess if you get a number, okay, let's see. So if I did that, so a sort of top level numbering, and versus this one, I think I'm taking advantage of the fact that we always have ifs or trailing. So if I say 0, 1, 2, 3, and I ask for slot 3, location 3, 0, 1, well, 3 is bigger than 1. So that must mean I need to get inside. Okay, so inside here, this is 1. Let's see, how am I doing this? I think it can work if I can express it and make sense of it. Okay, if I go, I think the way they always look is you can have a sequence of these things, but once you have an if, the sequence is over. That's always the last entry. Okay, I think that's the key. So let's see, if I ask for a number that's too big, 0, 1, 2, 3, okay, 0, 1, oh, you're too big. Well, take off the first one, skip how many you skipped, start your index at 1, ask for 3. Oh, how's that now? All right, what am I saying? If you ask for 3, 0, 1, well, 1's the entry of the first one. So 2, how do I describe this? Number segments at top level, then recurse in peeling off preceding statements. I don't know. Okay. I don't like the hierarchical numbering, because it just sort of sounds like, oh, you're going to get infinitely deep in these things, but somehow I have to be, well, maybe it's this case, right? This is 0, 1, 2. If I'm at line 20, location 0, and I ask for the next location, it should say, oh, that's line 20, location 1. And that part seems fine. But if I'm inside an if, let's see if I can make an example. So if I do this, maybe I can't make an example. Maybe that's the point. 1, 2, 2. Maybe the if is the one to push off. Okay, I think that might be the case. If these things were numbered like this, and you just ask for the next one, what I wanted to say is the next location is the current line number plus the current sequence point, 0, 1, 2. So if you're at 20 location sequence 0, 20.0 even, but I don't want to put points, 20:0, line 20, sequence point 0, and you ask for the next sequence point, well, if there's more on this line, then it should tell you, like, oh, the next sequence point is line 20 sequence point 1, and the one after that is 22, and the one after that is 25, line 25, sequence point 0. Okay. Let's make that work. Okay, so I'm wondering if our sequence construct is going to help with this or not. Where's that going to be? I guess locations in the interpreter. Okay, so I think I want to focus on this bit. All right, if next line number is not nil, then you definitely want to go to it. So you were in the middle of some line and you said go to 30, then you definitely should go to line 30, and reset your location, your location number. Okay. Back to Z. It should set back to 0, right? So this does that because it always sets it to 0. But choosing a new line number, that's a big deal. This one, program line after location line number, we don't really want to go there just yet if we're in the middle of something. If we're in the middle of a multi-byte line, okay, then the next piece should be the following sub line, or internal line. But maybe because we've done this sequence thing, let's go back up here. I guess it's down here, sequence. So sequence basically executes these steps. I don't. I'm definitely puzzled on this. Like, how can we best do this? If sequence is a set of steps, the problem is you can do go-tos and all kinds of stuff in there in those sets of steps. Right. The problem is, okay, go-to always says a line number, so he's not a problem. The for next, that's a problem. Maybe this is the high level and it's okay. But we got to find the location that goes up. This one. So, yeah, if we have, well, let's say we have line 25, x equals 1, GOSUB 3000, print x. Okay, the GOSUB should, and it's followed by line 30, whatever. GOSUB should say my following place is line 25, segment 2. But it only knows that. Oh. Wow. Okay, I guess one thing I'm thinking, again, I'm trying to find options. One option would be treat the line number as its own entity. And so the line number is sort of establishing I'm on line 25. Okay, until told otherwise. And then the rest of it is then sequences. It's sequences of line numbers and executable statements. What if we did things that way? Oh golly. Okay. Tell you what. Let's just take a 3-minute break. Clear heads. Come up with ideas. See what we can do. See you in a few minutes. All right, welcome back. Drop some answers in the comments. I did think of another option that we've got this program notion. The program right now is sort of it's kind of a hash map from line number to line, but we could ask it to give us fragments as well. And maybe that would be a step forward. I don't know if the hierarchical is so bad. I mean, we would probably do it as an array. Right, saying get the first component, and of that get the second component, of that get the third component. Maybe we should just spike this one. I mean, I've got this kind of intuition. I clearly am babbling about it, but not making myself clear to myself. So that's probably not clear to you. But somehow, I feel like if I know the top level thing, like I should be adding the. Okay, where's my example? I need an if statement example. All right, 0, 1, 2, 3. Okay, 0, 1, 2, 3. If I say give me segment 3, you go 0, 1. Oh, I can't count to 3. I've only got 2 here. So the fact that 3 is bigger than 1 says you must need to go inside. Okay, and I go inside, and 0 is the first one. Well, on the outside level, 1 plus 0 is 1. That's fine. 1 is the second one. 2. Okay. Now I go in 2. All right. Let's try. Yeah. Let's just spike a little implementation of this thing and see how it goes. This is location numbering spike. Okay. So I've got an array of 4 pieces. Can I use my stuff or do I care? Okay, let's take this. Yeah. So dot assign x equals number 1. Okay, what is? I guess I wanted to do even simpler. Not get my stuff involved, but let. Well, no. Somehow I have to be hierarchical, don't I? Okay, I don't need to be interesting though, so skip. And then this is an if. Maybe it's even a sequence. And I would never be able to put, if the sequence is corresponding to the one in an if, I would never be able to put another entry after that. Okay. Excuse me 1 minute. Okay. Let's see. Little kids just don't understand why you have to work. Okay, so in my if statement, if I have an if statement, that's always the last of any sequence. I mean, I could have more than one statement before the if, but once I have the if, it owns the rest of the line. Okay, so this implicitly the sequence is the last thing. Now, the same thing goes on for it. I might have something inside there, but if once I have a sequence in there, that sequence owns the rest of the line. Okay, so let's make this look hierarchical so we don't get quite as confused. Okay, there's the sequence, and then this sequence has a sequence. And these structures are always going to be leaning far right like that. Okay. What is this? This is list of type array of statement equals that. Okay. Yes. Okay, so sequence, skip. Oh, let's get the brackets right. Okay, that's the end of that sequence. That's the end of that. And this I don't need. Good. Okay, so now if this is at the global level, this is 0, 1, 2, 3, and 4. Okay. So it's like skip colon. If 1 equals 0, then skip colon. If x equals y, then skip colon skip. Maybe I should put that in my comment up here too. So this is skip. If condition, then skip. Condition, then skip. And this one is C2, then skip colon skip. Okay. It's a lot of skips. 0, 1, 2, 3, 4. So if I ask for the inside of the 0 slot of an if statement, I'm ignoring the condition. I just want the first thing. All right. And so the question is, let's assert equal. Oh. Every answer is always a skip, right? So I need something a little more interesting. Parse. Print. I got more arrays. How about go to? Or GOSUB? Okay, so this is GOSUB 0, GOSUB 1, GOSUB 2, GOSUB 3, GOSUB 4. Now I don't need these anymore because they are embedded. Okay, and if I assert, let's say at list 0, I should get 0 because the GOSUB is 0. Well, maybe it's, there we go. Okay. At is the function I'm making up, which apparently exists already. 2, 3, 4, 4. Okay, so if I ask for the slot at my linear index 0, 1, 2, 3, 4, I should get the corresponding one even though it has to dig in the nesting. That's what I want. All right, and then at here, it takes a list of statements and an index of int, and it returns a statement. Okay. Now, my naive view is if I just said return lists of index. All right, I think I might pass my first 2 tests. Non-optional statement. Lists of index, you gonna be happy? Okay. I think the first 2 will pass, but the third one will return the sequence instead of the GOSUB, and the fourth one will blow up. Okay, well, I don't know how we know how far we got. I guess we'll have to step through here. Over. This one I expect to fail. Can I call it? Print at list 2. Okay, it looks like a sequence, doesn't it? 0. Right, it's returning this sequence. That's kind of what I'd expect. Okay, this one I expect to blow up. Yep, okay. Failing the way you expect to is a good thing. Okay, so all right, so the deal is the last thing in the list is either a simple statement or it's a sequence. If it's before that, it definitely is a simple statement, and we should just return it. Okay, so I think if index is less than or equal to, well, if it's less than count minus 1, then this is naively is fine. Okay. Sorry, that's list.count. Okay. So the count of this list is 3 because GOSUB sequence. If you ask for slot 2, sorry, if you ask for 0, list.count is 3 minus 1 is 2. It's less than 2. 0 and 1 are less than 2. If it's equal to the last one, Okay. If it's equal to the last one and it's not a sequence, let's see, and there's no good way to say this is the problem as far as I know. Well, we can do a if case dot sequence so I can get the complaints out of the way. Okay. Stop debugging. Okay. If this thing is a sequence, then we got to do something else. If okay, so I've covered 0, 1. I want to cover 2. Let's take that off. So case 2, it is a sequence. I want to do this offset thing. Oh gosh. Okay. I guess let's just totally not worry about this case for the moment. All right. Let's kind of a step-by-step TDD. All right. So and if I don't know what else, I'll return .GOSUB 99 just to get out of this thing. All right. I can tell I'm going to be thinking about this all night. Okay, so here we are. If we know we're not a sequence because we're not the last thing in the list, then return it. Okay. If we are a sequence, well, the inner is the statements on the inside of our sequence. Okay. We're going to try and go for them. All right. But inner is a list of statements and we want to get a specific index. I think we can use the at to do that. Okay. So if it's there, then return at of inner. Now the index there, we got to adjust it, right? Because let's see. So in our example, we're on this sequence. If we ask for 2, we want to subtract off these 2, okay, and ask for 0 of this inner sequence. Okay, so the index is index minus, well, it's like list.count plus 1 or something like that. Okay, we're at slot 2. List.count is -1. Okay, let's see if we let's see if we get this one right. Okay, so we'll run this again. We got the first two. Step over, good, good. Print at list 2, and we expect to get GOSUB 2. Yes, okay. Now, and I think it might work on the others, right? Because recursion, right? Let's see. Okay. Blows up here. Oh, we haven't covered that case. Okay, so list sub 3 index is I guess this case applies if index equals list.count minus 1. I don't know if I can say multiple conditions. If index equals list.count minus 1 and this oh, I can do that. Okay. If index equals that, then that should be fine. If index is bigger than that, okay, if it's less than that, it's one thing. If it's equal to that, it's another. If index is greater than list.count, then what do we have to do? Well, we have to well, maybe this is not necessary. It's really, if we really want to look at list.count minus 1, okay, or list.last, maybe more accurately. Okay, so we know it's safe because, well, if there are any statements, it's safe. Okay, I don't think we would ever put one in with no statements, but we'll deal with that too. Oh, golly. All right. I guess let's just run the test. You start trying to convince yourself too much and you don't know if the test works. 0, 1, 2 should pass. Okay, so let's print at list 2. Good. All right, 3 didn't blow up. GOSUB 3 and 4. Oh, 99. Okay, that's that last case we didn't cover, is what if the last thing in a sequence is not a sequence, which obviously has to happen if we've got a finite list, right? So, okay, so if it's not a sequence, if the last one is not a sequence, then return lists of index. Is that right? So you ask for slot you ask for, let's say we had skip. You ask for slot 2, 0, 1, 2. List.count is 3, minus 1 is 2. So 0 and 1 come through this path. It list.last is a skip. It's not a sequence, so it doesn't go through this path. And we would just return it. Let's take this off and just continue. All good. Okay. Well, I'm not sure how to fold those together. Like, it feels like the first case and the third case should fold together, but if if it's a sequence and index, go list.count minus 1 and that, which is the same as this. If the index is greater than list.count, no. I did that wrong. Okay, if it's less than list.count, the opposite is greater than or equal to list.count minus 1. If you're greater than or equal to count minus 1, are you greater? No, what are you? Okay, let's see if this one works. Okay, yeah, I think this is all right. We'll fix this, take this out. But if your index says you're at the last element or further, and the last element is the sequence, then you should return the recursion. Otherwise, that. Okay. All right, so what does this prove? Well, it proves that my theory of indexing based on the overall position is feasible, right? Because we can step into our nested structure and find our way down to the corresponding place. Okay, so that is good. What I don't think we know yet is we don't know the count of this, right? There's nothing that tells us this has 0, 1, 2, 3, 4, 5 entries. Okay, we can see it, but there's nothing that tells us at the top level. We need to be able to ask at the top level, how big are you? And really, that's the size. I think that's the size of the numbers up to the last one, and then the size of the interior stuff recursively again. And the recursion is because these can go arbitrarily deep, these if statements. Okay. Oh, I'm feeling so good about that part. Okay, now whether we can make that work inside the thing, that's a challenge. All right, so I think we need to work out a function. Okay, so sorry, what we were doing was a spike global index at top level can find nested elements statements. All right, and we need we also need a function to count total statements. Okay, which sounds easy. All right. And if we had those, I think we could make current line no. I think we can take advantage of it. All right. So we're stopping there. I'm whipped, but I'm happy we found our way through this spike. All right. And we'll pick up there tomorrow. Next time is 10 a.m. Eastern Time to 12:30 p.m. or 3 to 5:30 p.m. UTC. Thanks for joining me today, and I hope I can see you in the future. So have a good evening and hope to see you again. Bye-bye.